that. All right. My name is John Hixson. I work for IX Systems. I'm a senior software engineer. I've been with IX for about almost 10 years now. These are the things I work on. I work mainly on FreeNAS, and then occasionally I work on TrueOS, formerly PCBSD. I'm working on another project called TrueView. I'll probably be giving a talk about that next year. And then I do some other open source work, FreeBSD, and some other random projects that you can find on GitHub. So the reason I decided to give this talk is I get a lot of people on the FreeNAS forums and the FreeNAS ticket system that are really confused about how these work and how, mostly, I'm also the Samba maintainer for FreeNAS, and once you layer Samba on top of ZFS, a lot of problems start to happen because people get confused and people lock themselves out of files, they can't access directories, and so on and so on. So that's my main motivation, hopefully to help that out. So, does anybody here not know what an ACL is? So ACLs are one or more access control entries. So, and they are evaluated in order. And the first rule that says the first entry that you come across that says you don't have access is where it ends, or it's evaluated further until you are allowed. So the order does matter. They're evaluated on the server. So if you're mounting a share from a client and the client thinks, no matter what the client thinks, the server has the final say. And that's all there is to it. ACL entries, they are made up of 4 or 5 entries that are delimited by colons. And 4 or 5, it's either 4 or 5 because depending on how the principal looks is whether it's 4 or 5. So the principal, actually I'll go over these in the next slide. So you have a principal, you have the permission set, you have the inheritance flags, and then you have the type of ACL entry that it is. So and the principal is made up of a tag and a qualifier. The tag will say, they'll either have an owner group for everyone, which I'll tell you how that works in a second, or it'll be a qualifier that specifies a user group. So in the case where there's 4 entries, you'll have, where's my pointer work? So the owner at that says that this entry applies to the owner of the file. The group at says that it applies to the group owner, and then everyone means not the traditional Unix permission everyone, but it means the owner group, and it's everyone including the owner and the group. So it is a little different than what you traditionally think with Unix permissions. And if a U or a G is specified, then you can specify a specific user or group, so you can get more fine-grained control over the file. I know it's not working. I got one too. Oh, the laser. I meant my things aren't. No, it worked. It worked at hooked up. Thank you. All right. So we have a laser now. So the qualifier is this means, so when you have the U or the G, right here, then you can, so back to the owner, if you have owner at, then you don't have to specify a qualifier. If you specify U or G, you have to specify the qualifier, which is either one of these guys, which I think you guys all understand what a username and a group name is. Here's the set of access permissions. I'm going to cover each of these individually. There's a lot of them. Some of these aren't used on FreeBSD, so I'm going to skip those. So R, W, and X, these work how you would expect them to work. They work the same way as they do with your traditional Unix permissions. So read, write, execute. And in fact, when you have a file or a directory and you do it, if you do an ls minus l on it, it'll look exactly like it would in the normal sense. Once you apply once you apply an ACL to the file, you'll see a plus. I didn't put it in my slides here, but you'll see a plus that indicates there's an ACL on the file. Any operation you use, chmod for, it'll work just like you expect. So I don't think these really need to be covered much. We all know what RWX is. Although I don't know if you guys can see this, but I did put an example here because I wanted to show that when so if you set a UMass, I was showing here that it looks exactly. Can you guys all see this, or is that too small? All right, yeah. Sorry about that. Well, anyway, when you chmod a file, you set a UMass, you create a new file, it works the same way as it would if you weren't using ACLs. So if you understand Unix permissions, you understand UMass, this all works exactly how you expect. And then when you start adding these extra access permissions, that's when things start to get different. So the first access permission that is non-standard is the P flag. And this flag, or access permission, it's ignored for files. And if you want to be able to create directories, you have to add it to the set of access permissions. So, can you guys see this, or is this too small? I tried to make these large enough, so I hope. So, here I'm just showing what the access permissions look like without the P. And then I go here to try to make a directory, and I get a permission denied. And here, use setup ACL to add modify and add and delete ACLs, by the way, in case you guys don't know that. So I add a P here to the existing permission set, and then I show that it's there, and then I go here to make a directory, and now the directory is successfully created. Make sense? Okay, yes? Capital D is for delete child, and also, so when you use setup ACL, you can use the short form or you can use the long form. I like using the short form, but if you want it to be English, understandable, you can use this as well. And this gives you the ability to delete subdirectories with 2 L's. So some of these examples, I like using a deny entry to make it more clear what you're doing here. So I have this directory here. I put a deny entry with the capital D. Here you can see that the capital D is in there, right there. And yeah, I come here, I try to delete the directory. I get an operation not permitted error. Minus X deletes the, if you set up ACL minus X, it'll delete the entry at this number, so 3 in this case is this guy right here, it's the last one. So I delete it, and now the permission set is back to what it was. I come here to remove the directory, and I'm able to remove the directory. Lowercase d, this is for the ability to delete a file. Oops. So some of these probably went a little too far with my examples. I just wanted to be thorough. I want to show that what the the access permissions look like before and after. So I create a file here. I show the default permission set. I cheat a little using chmod. And then down here, I create a deny for the ability to delete. And now you see it right here. So there's a deny entry for deleting the file here. You come here to try and delete it. This is a big no. I remove this entry here, and then I come here to remove it again, and then I'm able to remove it. Lowercase a is for the ability to read attributes. What are attributes? The stat structure, so timestamps, being able to read the inode, see the size, etc. So I had a deny entry for being able to read the attributes here. So here's the deny entry. I come here, I try to read the ACL, and I got told no again. I delete that entry. Now I attempt to read the ACL again, and I'm able to read the ACL. Capital A is for write attributes. I don't have an example for this because I guess probably one of the few attributes you would write from userland would be the various timestamps that are set on an inode, and I don't see why that'd be a very good example to show. So I'll skip that. I'm sorry?
Come to your tracks.
Why would you do that? Yeah. And read extended attributes and write extended attributes. These aren't used by FreeBSD. Maybe they will be one day if we have ZFS extended attributes. So lowercase c is for reading the ACL. So over here, let's see, listing how they look. I remove the ability to read the ACL. And this is just as a normal user. I try and read the ACL. Oh, hey, that's way better. Thank you. So I come here to read the ACL here. I get permission denied. I add the ability back here. And then I try and read it again, and I'm able to read it here. If any of these examples aren't making sense, feel free to tell me, because they're kind of hard to demonstrate when to people who are unfamiliar with ACLs. But I'm hoping these are working pretty well. Okay, so capital C is for writing the ACL. So here is example with capital C. That's for the owner. Okay, so I try and change here. So I try to chmod, and as always, get operation not permitted or not allowed. And then I update here so that you can write the ACL. Come back here. Use chmod, and it returns successfully. Lowercase o is for the ability to change owner or group ownership. So chown. So here I try to change ownership and I'm told no, I can't do that. I update the ACL to allow that, and now we can see that it's there again. And then here I change ownership and I'm able to do so. S is not used on FreeBSD, and I'm honestly not familiar with what S actually does. I think I read something somewhere that it's used on Windows. So the next up is the third or fourth field of the ACL entry, and these are the inheritance flags. I'm going to go over these individually as well. So the first one is file inherit. This means that all files in the sub. By the way, inheritance flags can only be set on directories. The exception is the capital I, which did I list that? Yeah, which just shows that the file was inherited, but it's not something normally you shouldn't set that. That should get set by the file system. So if F is set in inheritance flags, then all files in that directory will inherit that ACL entry. So here is a directory that has no inheritance flags. So if I create a file, it will inherit nothing. What am I doing here? So if I set file inherit down here, this right here, this field, this is where the inheritance flags get set. So I'm giving all of these a full set. Oh, that's what I did. Okay. I give these a full set, which means all of the control to everybody, and I do that for owner group for all the entries I have here. And then when I create a new file, that gets the full set. Directory inherit works the exact same way as file inherit works. Just means that the directories that you create in that directory will inherit the ACL entry. So I'm not going to show that. I, lowercase I, it's inherit only, and it's only usable if you set directory or file inherit on the ACL entry. And what it means is that only the files or directories that are beneath it will inherit. So basically it means that ACL entry, it doesn't apply to that current directory, so it's almost invisible, but newly created files and directories beneath that directory will inherit those ACL entries. So if you wanted to have, let's say you have a directory and it has a certain set of access permissions, and you want that, you don't want that to inherit, but you have a different set of access permissions. It's invisible to that directory. Only files and directories beneath it will inherit that. That's probably the best way I can explain that. So here I have a directory with all of these have the full set of access permissions, and then I set inherit only for group and everyone. And so now essentially this directory, the only ACL entry on this directory is this that will apply to this directory. These are going to apply to newly created directories and files underneath this directory. So I create a file here, and then I read the ACL, and now you'll see that this is inherited and this is inherited. And N, lowercase n is for no propagate. this one's kind of weird too. This has to be used with file or directory inherit as well. One of those has to be set. And this says that the immediate, the first level directory beneath where you're at is what will inherit those ACL entries that this is set on. Anything beneath newly created directories will not receive that inheritance. So it's one level deep and nothing else under that. Yeah, I'm very sorry about this one. So up here, I have a directory that has a full set, and I have file and directory inheritance set for the inheritance type. I make a directory here, sub1, and then I read the ACL, and that gets the inheritance that was specified up here. And then under the sub1 directory that I just created, I make another subdirectory, and then I read the ACLs, and that gets, wait a second, okay. Now, so that's the default behavior it'll inherit here. And now, when we come here, I set the no propagate flag on it, and it has the full set. So this is where we at? Sub. Okay, this is the current directory. So I set the no propagate on this directory here. I create a new directory within the subdirectory called sub2. And then when I look at these permissions, you see that it's inherited. And then, I'm sorry, this is so small. I guess I could have spread it out more. So now when I created, so underneath the newly created directory that I set the no propagate flag on, I create a file, and it doesn't propagate, it doesn't get those permissions. So I hope you guys can see that. It's small, I know. All right, then capital I means that the entry was inherited. So when you see capital I, that just means it was inherited. And the two types of ACL entries that we have in FreeBSD are allow and deny. I think Solaris has a couple of other ones. And these are straightforward. Allow means that the ACL entry, if it matches, it's allowed. Deny means that it's denied. So I think ACLs are pretty straightforward and easy. Hopefully you guys do too. And hopefully that made sense to you guys, and you all understand how they work now, because they're easy. Anybody have any questions? Does everybody jump at once? Yes.
So you've been talking about how they work in the context of ZFS, is that correct?
Yeah, yes, I'm sorry. I should have probably made that clear. Yes, ZFS. ZFS and ZFS only.
Right, because UFS does things, I mean, most of what you said applies to UFS, but some of the ones you said aren't done, are in fact done in UFS.
Yeah, I saw there's distinctions in UFS when you use NFSv4 ACL'S. I have very little experience with using those on UFS. I think it was in Michael Lucas's book that he actually showed some of those distinctions. So you feel free to tell me what the distinctions are. I'm curious too. But this does apply just to ZFS.
Yeah,
That's
that
the
was
world
really my question.
That's the world I work in, and also I'm more in tune with these when it comes to using Samba and NFS4. That's kind of the world I live in with these.
So presumably that's also what Microsoft is going to support, and Samba is essentially Microsoft-centric.
Yeah. And in that regard, the NFS4 spec, they intentionally made it to where these could map onto NTFS ACLs. Michael Dex?
Hey, have you seen command line or visual tools to simplify the management of ACLs?
Yes, I have. So on Windows, if you click property.
Exactly.
No, well, when you say that, that's, I mean, so in FreeNAS, we're actually going to write a UI to do that. But as far as I know, nothing exists to make managing these easier. In the realm I work on, which is FreeNAS, I recommend people manage these on Windows using the properties dialog because they are a pain, and I don't expect people to get on the command line and type out these set of ACL lines. I mean, I'm okay with it, but you know, most people aren't. Anybody else? Well, thank you for coming to my talk. I hope you learned something.